Good afternoon to everyone. Am I audible? Am I audible to you?
Yes, sir.
So, in this session, we will mainly discuss the number system, the questions, basic questions of number system. First of all, basic definitions of the numbers and the questions related to those basic definitions. And let us start with the first slide itself, where some definitions will be there. For example, you have these definitions of on numbers. They are actually important because you cannot ignore the types of numbers while solving the questions. So first of all, it is the natural numbers. So basically, natural numbers are those numbers which are used to uh, count something. So they are also called the counting numbers. So numbers 1, 2, 3, 4, etc. They are called the natural numbers. 1, 2, 3, 4, 5. If you keep on doing this, writing down this, you will get the set of natural numbers. So they are also used for the counting purpose. So that's why they are also called the counting numbers. They do not have any fractional part. So natural numbers basically start with the number 1, 1, 2, 3, 4, 5 up to infinity. Next, we have whole numbers. Now, the only difference between the whole numbers and natural number is that in the case of whole numbers, 0 will be included. If I include 0 to the set of natural numbers, the set that I will get is the set of whole numbers. So when we talk about the whole numbers are nothing but 0, 1, 2, 3, 4, 5, and so on. So if I add 0 to the set of natural numbers, I will get the set of whole numbers. So from this discussion, I can say that every natural number is a whole number. Every natural number is a whole number, but the converse is not true. Every whole number is not a natural number because there is one whole number 0, which is not considered as the natural number. Next is the integers. So what are integers? Basically, if I take the whole numbers as well as their negatives, whole numbers are 1, 2, 3, 4, 0, 1, 2, 3, 4, and up to infinity. If I take the negatives of these numbers also, obviously negative 0 will 0 does not mean anything. So negative of 1 is -1, -2, -3, -4, etc. If I take these numbers also, what we will get is we will get the set of integers. So set of integers is nothing but the that is the set containing whole numbers as well as their integers. So natural numbers, they start from 1, 1, 2, 3, 4, 5. If I add 0 to that set, I will get the set of whole numbers 0, 1, 2, 3, 4. And for integers, if I take the negatives of the whole numbers, then I will get the set of integers. So I can say that natural number is, all the natural numbers are contained in the whole numbers. Every natural number is a whole number, as well as every whole number is an integer. But again, converse is not true. Every whole number is an integer, but converse is not true. Every integer is not a whole number. Every integer is not a whole number, since -1, -2, -3, etc. They are the integers, but they cannot be considered as the whole numbers. They are not considered as the whole numbers. Next, this is the definition which generally examiner used instead of natural numbers and whole numbers. Normally, examiner used positive integers, negative integers, and non-negative integers as the definitions. So whenever we say positive integers, that simply means only the natural numbers. The reason being, 0 is neither considered as positive nor negative. 0 is neither positive nor negative, right? So when we talk about the positive integers, they are just 1, 2, 3, and so on. They are 1, 2, 3, 4, 5, and so on. These are the positive integers, or you can also say that they are the natural numbers only. Negative integers, right? Again, 0 is not considered as negative. So negative integers are -1, -2, -3, etc. And when we talk about the non-negative integers, and as I told you that 0 is neither considered as positive, 0 is not positive, not negative. So if it is not non-positive, it is also non-negative. So when we talk about the non-negative integers, then 0 will be included. So that will be 0, 1, 2, 3, 4, and so on. Means you are getting the set of whole numbers. Now what happens these days, instead of using the words natural numbers or whole numbers, examiner generally use the words positive integers, non-negative integers, etc. So whenever he is asking you the positive integers, you should know that he is asking for the natural numbers, and whenever he is talking about the non-negative integers, that simply means he is talking about the whole numbers. So is this clear? Up to this point, the definitions are clear to you? Please use the chat box so that I could get to know that whatever I am telling you, you people are able to grasp that. Let us now do one two simple questions. I told you that these definitions of numbers, they cannot be ignored at all. You must keep these definitions into mind while solving the questions. Natural numbers, whole numbers, integers, right? Positive integers, negative integers. Because if I just change the question from natural number to whole number or from whole number to integers, the answers will change. Let us check the first question. It says, what is the smallest integer with which 23 by 99 should be multiplied so that it becomes an integer? What is the smallest integer with which 23 by 99 should be multiplied so that it becomes an integer? Are you solving this? Please use the chat box in order to answer the questions. What is the smallest integer with which 23 by 99? My fraction is 23 by 99. Question is asking with which smallest integer it should be multiplied so that it becomes an integer. This is a fraction. So what is the answer? Is it 11? Yes or no? If I multiply this number by 11, will I be able to get an integer? If I multiply it by 11, what I will get is 23 by 9. Is it an integer? No one is interested in answering the question. So how will this question go on? It should be a two-way communication. It's not like that I am here just to solve the question and move over. So this is not an integer, obviously. So answer cannot be 11. Yes, good. So answer that now. I just asked you that is it 11? So what do you think the answer should be? I am not saying that this is answer. So what should be the answer? Which smallest integer should be there with which this 23 by 99 should be multiplied in order to get the integer? You tell me the answer. Is it 33? How will you get an integer? First of all, the question rises, how will you get the integer? This is the fraction with you. How will you get the integer from this? Obviously, you need to multiply it by such a number that this fraction, this denominator part cancels. You have to multiply it by such a number that the fraction in this fraction, the denominator is deleted or it is cancelled completely. Only then you will get a result which is of an integer. So I just asking you that which smallest number should be this. If I multiply it by say 99, for example, this 99 will cancel out. So answer comes out to be 23, which is an integer. If I multiply this fraction by say 198, in that case, this will be 99 into 2, 198. So this becomes 23 to 2, 46. Again an integer. If I multiply this number by say 297, which is the third multiple of 99, I will get 69. After cancelling 99 into 3, I will get 3 into 23, which becomes 69. Again an integer. Right, so you are getting a lot of numbers with which this 23 by 99 should be multiplied so that it becomes an integer. The question is asking for the smallest one. What is the smallest integer which will be used, which can be used to get the integer? This is the question. So what do you think? Should be the answer 99? 23 by 99 into 99 will give you 23. Is the answer 99? But what if I multiply it by 0? If I multiply it by 0, it will become 0. Isn't the 0 an integer? So shouldn't the answer be 0? 23 by 99, if I multiply it by 0, I will get 0. 23 by 99 multiplied by 99 will give you 23. Here is you are getting integer, 0 is also an integer. So shouldn't the answer be 0 instead of 99? Or do you think some other number can prop up also? If I multiply this 99, now the thing is that we are talking about the integers here. Integers, what are integers? Integers are whole numbers 0, 1, 2, 3, etc. and their negatives also. So integers are not only the positive ones, they can be negative also, -1, -2, -3, and so on. They are the negative integers. And since the question is asking for the integers, that simply means it is not that we will check the positive part only, positive integers only. It could be negative also. Reason being, question is asking for the smallest integer. Now, what if I multiply this number by minus 99? What will happen in that case? Will it not be equal to minus 23 in that case? Minus 23 is an integer. What if I multiply this number by minus 198? In that case, it will become minus 46, again an integer. Now I know that minus 198 is less than minus 99. So what will you get from this discussion? What should be the minimum number? Obviously, the minimum or the smallest cannot be found, cannot be determined. The reason being, I can take this number as small as possible. Just keep on writing the zeros for the whole of your life, rest of your life, and even then you will get an integer at the end. Answer would be cannot be determined. It can go to minus infinity. Yes, any negative number up on any negative multiply a multiple of 99, sorry, any negative multiple of 99 which could approach to infinity. Answer would be cannot be determined in this case. Now, if instead of this integer, if I change the type of the number, smallest, if instead of in smallest integer, if I ask you what is the smallest natural number, what is the smallest natural number, so that it becomes an integer. Now what would be the answer? Yes, in this case the answer would be 99, because if you multiply it by 99, then it will become an integer. That means for the given question where the integer was asked, answer was cannot be determined, but if I take that category of number as natural number, then answer will be 23. And if I ask you, instead of natural number, if I ask you smallest whole number, in that case answer would be 0, because if smallest whole number is 0, if you multiply it by 0, you will get 0, and 0 is an integer. So that simply means for the same question, if I use the category of numbers as integer, answer will be cannot be determined. If I use natural numbers, answer would be 99. If I use whole numbers, in that case answer would be 0. That means these definitions of the numbers are important. Natural number, what are natural number, what are whole numbers, what are integers, you must know them. You cannot ignore these categories, because the whole answer will be a different one if you just change the category from natural to whole number or from whole number to integers. I hope this is the first question and this is clear to everyone. Any doubt you can please ask me. You can unmute yourself also. Shall we move to the next one then? Product of two integers is 28. What will be their minimum possible sum? Product of two integers is 28. What will be their minimum possible sum? Now in this case, what is happening is you are having two integers, let's say a and b. Their product is given to you as 28. Now question is asking for their minimum possible sum. You need to check those integers which will multiplied, when multiplied will give you 28, but on the other hand side, when you add those two, you will get the minimum sum. Think about the numbers. What could be the numbers whose product is 28 and their sum is minimum possible? There are a lot of cases. It could be 28 into 1, it could be 14 into 2. There are so many cases, but you need to take that those numbers into consideration for which the sum becomes least. Okay, Astha, you are saying this number 14 into 2. Akash, you are saying 4 and 7. Okay. Any other answer, please? Any other answers? Astha, Akash, and Anish, they are saying 7 and 4. So their sum is 11. Their product is 28 also, but their sum is 11. In your case, you are saying 14 into 2. So although your product is also 28, but the sum in your case is 16. So do you want to change your answer? Or do you think that Akash and Anish, they have answered wrong? There could be other possibilities also. Yes, Akash, you should think about that also. Question is asking for the integers only. It is not asking only the natural numbers. What you people are missing again is that product of two integers is asked to you, not the product of two natural numbers. When you take the numbers to be 7 and 4, you are just considering the natural numbers only. But since question is asking for the integers, they could be negatives also. So if you are taking 7 and 4, 28, don't you think that minus 7 and minus 4 will also be 28? In that case, the sum will be minus 7 minus 4 equal to minus 11, which is lesser than the sum given by you, which is 11. Very good, Akash. Or any other case, minus 14 minus 2, that is also 28. But in this case, the sum becomes minus 16. If I take minus 28 and minus 1, in that case also the product will be 28 and sum will be minus 29. Answer is minus 29. Yes, it is not 11, it is not 16 or minus 11, it will be minus 29. Is this clear? Any doubt? So for integers, the answer to this question is minus 29. If anyone has doubt, please ask me. So otherwise, I am moving to the next part now. For integers, the sum is minus 29. Now, please tell me what will be the sum if instead of integers I take natural numbers? What is the answer in that case? For natural numbers, what will be the answer? Obviously, when you are considering the natural numbers, you cannot go on the negative side. In that case, you have to just consider the positive numbers only, positive natural numbers and positive integers only. So answer would be in that case 7 plus 4, because 7 into 4 will give you 28, and this is the lowest combination of the numbers which add up to the lowest sum. Answer in this case would be 11. For the case of natural numbers, answer is 11. Now what if instead of integers or natural numbers, if I use a word numbers only, product of two numbers is 28. Now what will be the answer?
Sir, then it can be negative and positive also, right?
Which one?
If we put numbers.
Yes, numbers can be positive and negative, obviously. Numbers simply means real numbers. So what will be the answer? For the numbers, what would be the answer? No. Actually, when we talk about the numbers means now you can, I'm not saying that integers or natural numbers or whole numbers. I'm saying the numbers. So when we talk about the numbers simply means real numbers. And in the category of real numbers, fractions also form the part, or rational numbers are also the part of numbers. So fractions or real numbers, they are also included. So when we talk about the numbers, in this question, the restriction for me was that I could not go beyond this -28 and -1. The reason was the question was asking for the integers only. But if instead of integers we use numbers, that means now we can also consider the fractions. So in this case, -56 multiplied by -1/2 again will give you 28 as a product, and sum in this case now becomes -56.5. Or you can also say that -84 multiplied by -1/3 again give you 28, but sum in this case would be -84.33, and so on. That simply means that you can keep on decreasing this value as per your wish. It could be very, very small, -84, and let's say you are putting an infinite number of zeros with that -84, and then you are multiplying that number by -1/3, and with this 3 in the denominator you are putting as many zeros as you have put along with 84. The sum, the product again will be 28, but sum in that case would be very small. So that means if I use only numbers instead of integers, in that case also, for the case of numbers, the answer will be cannot be determined. So again, for integers -29, for natural numbers 11, for numbers only the answer would be CBD, cannot be determined. Now I think it is now clear to you that the definition of the numbers is very important while solving the questions. You cannot ignore that part. The product of three distinct integers. Now instead of 2, you are getting three distinct integers and their product is 24. Now you tell me please, what will be their minimum possible sum? Product of three distinct integers is 24. Instead of two integers as in the previous question, now you are getting three integers. What will be their minimum possible sum? Product of three distinct integers is now there. That means you are having now integers ABC. Their product is given to you as 24. You need to find the minimum sum of A and B and C. A plus B plus C. Its minimum value is asked. Again, the numbers in the category of numbers in the question is the integers. So you have to take the integers into consideration. Integers means you could be taking positive as well as the negative integers also. So product of three distinct integers is 24. What are the possibilities? Okay. But in that case, the product will be negative. If you take all the three numbers negative, the product will be negative. A into B into C should be 24. The product is positive. That means you can at most take two numbers negative among A, B, C. You cannot take all the three negative. One of them will be positive definitely. So possibility is that you are taking A to be say -8, B as -3, C as 1. This is one of the possibilities. Or it could be -12 into -2 into 1. This could be the second possibility. Or it could also be -6 into -4 into 1. You can take at most two integers as negative ones. Or it could also be -24 into -1 and 1. Now, what do you think? Which triplet will give you the least sum? The sum in the first case is numbers here used are -8, -3, and 1. In this case, sum is -10. In this case, it is -12, -2 plus 1. It is -11 or -13. Here they are -6, -4 plus 1 means -9. In this case, they are -24 plus 1 and -1. So -24. So minimum sum is -24. That can happen if you take the numbers to be -24, -1 and 1. So you have to think about the numbers yourself in this way. Which triplet can I use so that the product becomes 24 and the sum is minimum 1? Okay, you need to think about the numbers. Only then you will be able to solve the questions like this. And they are very common questions while you are attempting for an entrance exam. You might get the questions of these types because many times examiner tries to check your thought process, check your ability to think about the numbers, etc. Right? So you might get the questions of these types. Is this clear? The logic is that when the sum is asked you to be the minimum one, you will take one negative number as great as large as possible. In this case, the product was 24. Minimum sum is asked, so you will take one negative number as large as possible. In this case, I have taken that number as -24. So I took one number to be -24, second one as -1, and the third one as 1. So the answer, the sum in that case becomes -24 plus 1 minus 1 equals to -24. Now this is the question which is, what do you say that, reverse of the previous one. It says the sum of three integers is 24. What will be their maximum product? Now sum is given to you. A plus B plus C. Sum is given to you as 24. What is the maximum possible product? Think about the numbers whose sum is 24 and their product could become the maximum one. Okay, Akash. Good. Akash has given the numbers 8 plus 8 plus 8, 24. So that their product becomes 8 multiplied by 8 multiplied by 8, 512. Any other suggestion on this? Or anyone Is there anyone who want to change this answer, or you people will go with this answer? What do you think? Should we go with this answer, or we should change the answer? Please use a chat box, or you can also unmute yourself. If you are not comfortable in typing, or you don't want to type in the chat box, then please use the microphone and you can unmute yourself and you can tell me your answer directly. So do you want to go with Akash's answer, or you want to change this one? Okay, Akash, your answer would have been correct had the type of number been natural numbers. Yes, Asta. But in that case, Asta, the product would be lesser. 15 into 3 into 6. It is 90 into 3, 270. Whereas Akash answer is still greater than this one. If instead of integers we use natural numbers, then this would have been the right answer. Akash, please check that. If I ask you about the three natural numbers, if the sum of three natural numbers is 24, then your answer would be correct. Nothing wrong in that. The numbers would be 8, 8, 8, 24, and product would have been 512. Now, can you tell me what you are missing right here? Why your answer is wrong? Because the question is not asking for the natural numbers, it is asking for the integers. And when the question is asking for integers, you can take the negative ones also. Okay, अगर integers हैं तो negative भी हो सकता है. Your answer is correct in the case of natural numbers only. Let us take an example. Just an example. What if I take A to be say 800? A is 800. B is say minus 400. And C is minus 376. Isn't the sum still 24? But in this case, the product is very large. It is 800 multiplied by minus 400 multiplied by minus 376. Since I have taken two negative integers, so end product will be a positive number. So this will be a positive number, but very large as compared to 512. Now this is one of the examples. You can take this 8,000 as 800 as 8,000, 8 lakh, 8 crore, or 8 trillions. So you can take this number as large as you wish. You can take that corresponding two negative numbers in such a way that the sum of the three numbers become 24. Are you getting this? In that case, the product will be very large. So if you are taking the integers, again, answer will be cannot be determined. But if instead of integers, I take natural numbers, then answer would have been 512. Then all of them should be equal. Yes, Freddy, you want to ask something? Okay. I hope this is clear now. Now try this one. Now the product of 4 integers is 36. What is the minimum possible sum of these integers? You are having 4 integers, say A, B, C, D, whose product is given to you as 36. So A multiplied by B, C, D, their product is 36. Question is asking you the minimum possible sum. I told you that in such kind of questions, when the product is given to you and sum is asked, it is better to take one integer on the negative side as small as possible. In this case, that can be taken as, since the product needed is 36, that can be taken as minus 36. Numbers are 4 now. You have to take 4 integers. So take one of them as small as possible on the negative side. Since the product required is 36, so one can be taken as minus 36. Now, there is one more change in this question as compared to the previous ones. In the third question, we also did the question, this one, when we took minus 24, minus 1 and 1, if you remember that. Here, 3 distinct integers were asked. Word distinct was given to you. But in this question, the good thing is, distinct word is not there. That means there is no obligation to take the distinct integers. You can take the integers to be same also. So what I am doing is I have taken one integer as small as possible on the negative side. Since the product is 36, I cannot go below 36, minus 36, sorry. And the rest of the 3 integers can be taken as minus 1. Since we have 4 integers, so our remaining 3 can be taken as minus 1. In that case, again, you are getting the product as 36. So what is the smallest sum or the least sum? Sum would be minus 36, minus 1, minus 1, minus 1. So answer would be minus 39. In this case, the answer is minus 39. Is this clear?
Yes, sir.
Right, good. Now try this one. N is a positive integer, then 3 raised to power 4n minus 4 raised to power 3n is always divisible by which among the following given options? No, n is a positive integer. So question is asking which among the given options will divide this number. Number given to you is 3 raised to power 4n minus 4 power 3n. Since n is a positive integer, so n can take values 1, 2, 3, and so on. Now this question simply means that whatever the answer among these four options is, that answer is valid for n equal to 1. That answer will not change if you change the value of n. That will be valid for n equal to 2, will be valid for 3, 4, and so on. That means I do not know whether the answer is option 1, 2, 3, or 4, but whatever the answer is, that answer is not going to change if you change the value of n, because that answer has to be the universal one. That answer should be true for every value of n. N is a positive integer. Question simply asking which among the following will always divide the number. That means the answer will not change whatever the value of n you take. And since n is a positive integer, very good Paddy, answer is positive integer, and the least positive integer is 1. Just put n equal to 1 and try to find the number. Number is 3 raised to power 4n minus 4 power 3n. Put n is equal to 1 here. If I take n to be 1, my number would be 3 raised to power 4 into 1, that will become 4, minus 4 raised to power 3 into 1, 4 cube. Now 3 raised to power 4 is 81. 3 power 4 means 3 multiplied 4 times. So 3 into 3 into 3 into 3, this will be 81, and 4 cube will be 4 multiplied 3 times, 4 into 4 into 4, that will be 64. Their difference comes out to be 17. Now 17 among the given options, if I take the options with me, 142, 17, 112, and 7, I can check that this 17 is divisible by 17 only, means the second option. That simply means the answer has to be the option 2. 17 is the number which can divide every number of this form, 3 power 4n minus 4 power 3n, whatever the value of n is, whether it is 1, 2, 3, or any other natural number. I hope it is clear. Next, we have the next definition of rational numbers. We just discussed the definitions of natural numbers, whole numbers, and integers. Next is a rational number. So any number which can be written as P over Q form. Rational means basically the numbers which have come from ratios, right? So ratio generally is taken as if it is 2:3. We generally can write it also it like 2 by 3 also. So rational numbers are those numbers which can be written as P over Q, where P and Q, they are the integers. P and Q are integers, and Q is non-zero. So in this case, you can say that all the fractions will be the part of the rational numbers. 2 by 3 is a rational number, 5 by 12 is a rational number, minus 17 by 8, minus 11 by 15, 15 by 102. So all these numbers, they are rational numbers which can be expressed as P over Q form. They all becomes a set of rational numbers. Now, if I ask you one question, please answer that. Is 8 a rational number? Yes or no? Is 8 a rational number? Is 8 of the form P over Q? Yes, good Sunny. 8 is of this form also. Reason being, you can write 8 as 8 upon 1. 8 can be written as 8 over 1. So P is 8 and Q is 1 here. 8 is also a rational number. So if 8 is a rational number, that means all the other natural numbers will also be rational numbers. So as the case of negative integers, minus 17 can be written as minus 17 upon 1. So this is again a rational number, right? So that simply means that every integer is also a rational number. You take any integer, 20 is 20 over 1, minus 50, it is minus 50 over 1. So you can take any integer, every integer is a rational number. Okay, so every natural number was whole number, every whole number was integer, every integer is a rational number. So that means we can collectively call all these numbers as the rational numbers. There are two other type of numbers. In fact, they are also these forms only, but their representation is a little bit different. The first one is a terminating decimal. Whenever you have a terminating decimal, that terminating decimal can also be converted into the rational numbers. Now, what is a terminating decimal? A decimal which terminates, which ends, that can be converted into the rational number. Very simple example, 0.25. If I write just 0.25, it is a decimal, but a terminating one. The reason being the decimal ends after 5. There is no digit after 5, so it is a terminating decimal. It is a ending decimal. This can be converted into the what you say rational number by writing it like 25 by 100. 0.25 is nothing but 25 by 100, which can be written as 1 by 4. So it is again a terminating decimal. The second category is when you have a non-terminating decimal. So non-terminating decimal, but non-terminating recurring decimals. Recurring word should be there also. Recurring means a repeating decimal. So non-terminating but recurring decimals or repeating decimals, they are also rational numbers. Now, what does it mean? Non-terminating simply means that decimal is not terminating at all. It is keep on adding the digits to itself, right? It is never ending. But repeating or recurring means the digits which are used to write down that decimal, those digits are following a certain pattern. They are appearing in the decimal uh, using a certain pattern. That is not the random representation of the digits. The digits actually are appearing in the number by a certain pattern, by using a certain pattern. For example, if I write the number, let's say 1.33333333 and so on. Now this 1.333333, yes, very good, Sunny. That is also the case. So 1.33333333, right? You are getting a never-ending decimal, but the digit that you are using in the decimal part is 3 only. And if you can recall, this number is nothing but 4 by 3. 4 by 3. If you divide 4 by 3, you will get this number 1.3333 and so on. Sunny has given another example, 0. Say 21212121 and so on, or you can also take 1.21212121 so on. The basic logic is that the digits after the decimal, even if they are never ending, they should be repeated by using a particular pattern, right? So these kind of numbers where the non-terminating recurring decimals appear, they can also be expressed as a rational numbers, just like 1.333 is nothing but 4 by 3. So next definition comes from the this second point only. Then next definition is of irrational numbers. Before this one, we will discuss this definition. Definition of the irrational numbers. Now, irrational number is nothing but it is the non-recurring decimal, right? Infinite means non-terminating. Infinite means non-terminating, non-recurring decimal. So if you get the non-terminating, non-recurring decimal, then such a number is called the irrational numbers. For example, under root 2, under root 5, even the cube roots of the numbers whose perfect cubes cannot be found, say cube root of 3, cube root of 7, right, cube root of 15, all these are irrational numbers. Pi is also an irrational number. We generally write that pi is 22 by 7, but that is not the accurate value for pi. Pi is also an irrational number, right? So it is a never ending decimal, and also the digits in that decimal, they are not appearing with a certain pattern. So whenever you get such kind of number where the decimal is never ending, non-terminating, but the digits are uh, appearing in the random manner, not following any pattern in the decimal system, then that number is called the irrational numbers. Third, simply any root of number which cannot be exactly found, that is called the root, the third. Now let us come to the questions. These two questions which we left in between the definitions. Sum of two numbers is 30. What is the maximum possible product for these two numbers? sum of two numbers is 30. Maximum possible product for the numbers. You need to find the maximum value of the product. Good, Sunny. There are a lot of possibilities for the two numbers to add up to 30. One of them is 30 plus 0. Now, in this case, the numbers used are 30 and 0. So product is 0. Next is 29 and 1. But in this case, the product will be 29 only. Next is 28 plus 2. In this case, the product is 56. Next is 27 plus 3. Product is 81. 26 plus 4. Product is 104. Now, what you can analyze from this series? If you take the numbers to be 30 and 0, then the difference between the numbers is 30. The product is 0. If you take the numbers to be 29 and 1, difference comes out to be 28. Between the numbers, the difference is 28. The product is 29. Next case, numbers are 28 and 2. Their difference is 26. The product becomes 56. In the next case, the difference becomes 24. The product becomes 81. In the next case, the difference becomes 22. The product becomes 104. So can you see that if as the difference between the numbers is decreasing, 30, 28, 26, 24, 22, as the difference between the numbers is decreasing, the product is increasing. Product was 0, 29 and so on. So when the difference between the numbers is decreasing, the product is increasing. Okay, so minimum difference will be when maximum product will be when the difference between the numbers is minimum. When the difference is decreasing, the product is increasing. So maximum product will be when the difference between the numbers is minimum, and minimum difference can be 0. That will happen at 15 and 15. When you take the numbers to be 15 and 15, in that case, the difference between the numbers will be the minimum 0. And product in that case will be 15 into 15, 225. So this would be the maximum product, considering that the sum of two numbers is 30. Maximum product will be 225. Is the discussion clear? Now let us change the number. Instead of 30, if I take the number say 21, what would be the answer in that case? Instead of 30, if I take the number to be 21. No, so the problem is that if I take one number to be positive and one as negative, 800 and minus 770, that also becomes 30. But you have taken the numbers to be to 800 and minus 770. Now, when you multiply these two numbers, whatever the product you are getting, that product is negative 1. But question is asking for the possible maximum product. We did this when we have to take the three numbers. When we had taken three numbers, in that case, we could do that because there was a leverage for me to take. I think that this was a question, if I remember correctly. In that case, I took one number to be positive and the other two to be negative, so that their sum becomes 24. That could have been done when the numbers were 3. The reason being, now when you multiply these two numbers which are negative, you are going to get a positive result. Right? That leverage is gone now, since we are having only two numbers. So I cannot take one to be positive and one to be negative, because in this case the product would be negative. That is simply not possible. This question is asking for the maximum product. Okay, in this case we are not yes, right. Sunny, you saying 110. Okay, now I told you that instead of 30, what will be the answer to this question if I take the number to be 21? What is the answer in that case? Again, 21 can be 21 plus 0. Product is 0. it can be 20 plus 1, product is 20, 20 and 1 has the product 20. It can be 19 plus 2, 21, product will be 38, and so on. The question is asking maximum product. So what should be the answer? Will it be Sunny? I think you made a small mistake in the calculations. I think. Will it be 11 and 10 or something else? Yes. Actually, 110 would have been the answer if instead of numbers, question says sum of two natural numbers. If the question says sum of two natural numbers is 21, then answer would have been 110. Because in that case, you can take only the natural numbers. So answer would be 11 and 10. You cannot get the difference 0 here. The minimum difference in this case, which you can get for the natural numbers would be 1. When you take the numbers to be 11 and 10. But now the number natural is word natural is not written there. So you can take the numbers to be decimals also. So 10.5 plus 10.5, not 11.5. It is 10.5 plus 10.5. That becomes 21 also. Difference is 0. So maximum product would be when you take the numbers to be 10.5 and 10.5. And in that case, that will be 110.25. This will be your answer. So if the question asks you that sum of two natural numbers is 21, answer would have been 110. Otherwise, if simply numbers are asked to you, answer will be 110.25. This is the same question which I just used here. Real number means set of all the natural numbers, whole numbers, integers, rational, irrational. So if you take every number into consideration, whether that is a natural number, whole number, integer, rational, irrational, if you take all the numbers and form one single set, that set will be called the set of real numbers. So whenever we say real numbers, that doesn't mean that real numbers are only the 1, 2, 3, 4 or -1, -2. Real numbers can include natural numbers, it can include whole numbers, it can include integers, rational, irrational, every kind of number. Simply the number with which iota is not written, that number can be categorized as a real number. Okay, just write down two results here. In fact, not two, you should write some of the results. Sum of first n natural numbers. Can you tell me sum of first n natural numbers? What will be the sum for this? Sum of first n natural numbers. First n means starting from 1. The formula to get this is n into n plus 1 by 2. So if someone asks me that what is the sum of first 20 natural numbers, my value of n becomes 20. It will be 20 into 21 by 2. Put the value of n equal to 20 here. It will be 20 into 21 by 2. So the answer comes out to be 210. Okay, so sum of first n natural numbers is given by this relation n into n plus 1 by 2. This is also written as like this, summation n. Summation sign means you have to add first n natural numbers. Next, if I ask you the sum of the squares of first n natural numbers, sum of the squares of first n natural numbers. Now that will be n into n plus 1 by 2 whole square. Sum of squares of, sorry, my mistake. That will be n into n plus 1 into 2n plus 1 by 6. Sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. Again, you are now finding the sum of the squares of the numbers. If Question is 1 square plus 2 square plus 3 square up to 20 square. Means you are finding the sum of 1, 4, 9, 16, 25 up to 400. Sum of squares of first 20 natural numbers. So put n equal to 20 here, you will get 20 into 21 into 41 by 6. Okay, put the value of n to be 20 and simplify this, you will get your answer. 2870. So sum of squares of the first n natural numbers is given by n into n plus 1 into 2n plus 1 by 6. Next we have sum of the cubes of first n natural numbers. Sum of cubes of first n natural numbers. Now that is equal to n into n plus 1 by 2 whole square. Sum of the cubes. So if I need to find a sum of cubes of say first 20 natural numbers, the answer would be 20 into 21 by 2 whole square. It will be square of 210, which is 44,100. So sum of first n natural numbers is given by this result, this simple formula, n into n plus 1 by 2. Sum of the squares of the first n natural numbers is given by n into n plus 1 into 2n plus 1 by 6. And sum of the cubes of the first n natural numbers is given by this formula. Next, if we have sum of the squares, the first formula is for the sum of the first n natural numbers, right? Means 1, 2, 3. So you are having both the numbers, even as well as odd. But if you if question asks you that sum of first n odd natural numbers, only the odd ones, not the evens, first n odd natural numbers, means 1 plus 3 plus 5 plus so on up to, right, up to say 39. That is given by the formula n square. And sum of first n even natural numbers is given by n into n plus 1. Right. So these are the some of the formulas which are helpful. Sum of first n odd natural numbers is given by n square. Sum of first n even natural numbers is given by n into n plus 1. Now, based on this, answer this question, please. And I expect answer from everyone now. Sum of the odd numbers, odd natural numbers up to 60. Right, good, Sunny. Sum of the odd natural numbers up to 60. So how many odd numbers are there up to 60? Up to 60, how many odd natural numbers are there? We have these numbers with us. Yes. Obviously, up to 60, I can say that half of the numbers will be even, the remaining half will be odd. So total number of odd numbers up to 60 will be 30. Sum of the odd natural numbers up to 60. So I can say that there are 30 odd numbers up to 60. So their sum is given by n square. Answer is simply square of the 30. That means 900. Now try this one, please. Right, Freddy? Right, Sunny, good. So m is an odd integer, n is an even integer, which of the following is always true. Best is to take the numbers. M is an odd integer. Let's say m is 3. N is an even integer. Let's say n is 2. Now put the values here. This is 3 multiplied by n minus 1 becomes 1. So this will be 3, not an even number. M minus 1 becomes 2. Since I have taken m to be 3, so 3 minus 1 is 2. 2 multiplied by any number has to be even. So this is not the right answer. M into n, 3 into 2 will be even. That is not true here. It says odd. M minus 1 will be 2. N minus 1 will be 1. And their product is even. Answer has to be option 4. Obviously, if m is an odd number, if you subtract 1 from m, that will become an even number. Even number multiplied by any number will give you even result. Answer has to be option 4. Next, what are prime numbers? Basically, those numbers which are divisible by 1 and the number itself, or I should say that numbers which have exactly 2 factors. One factor is 1, other one is the number itself. Yes, Sunny. Right, so those numbers are called the prime numbers. 2, 3, 5, 7, etc. They are all the prime numbers. 2, 3, 5, 7. In fact, these are the first 25 prime numbers up to 100, less than 100. 2, 3, 5, 7, 11, 13, 17. So whenever we do the course, we recommend generally that you must remember these prime numbers because they are very important. They will be used again and again. So you should have the idea about the numbers less than 100, which are prime numbers, so that when you come across such numbers in the paper, you do not need to think that whether this number is a prime number or not. Right? When it comes to 59, you should be advanced. You should be able to answer that yes, 59 is a prime number, 61 is a prime number, 89 is a prime number. Right? So we generally say that when we discuss a course, when we cover the course, we generally tell the student that you must remember the first 25 prime numbers by heart. They are very important. And prime numbers which are greater than 3, they can be expressed either in the form of 6n plus 1 or 6n minus 1. They can be written in this form. Right? Prime numbers which are greater than 3, they can be written as either 6n plus 1 or 6n minus 1 form, where n is n natural number. For example, 5. If I take 5, this 5 can be written as 6 into 1 minus 1. 43. 43 is a prime number. It can be written as 6 into 7 plus 1. In the first case, n is 1. In this case, n is 7. 59. 59 is nothing but 6 into 10 minus 1. 71. 71 is 6 into 12 minus 1. So you take any prime number minus 1. You take any prime number. That prime number can be written either 6n plus 1 or 6n minus 1. Right? But that prime number should be more than 3. Now the converse of this result is not true. That simply means that if a number can be written as either 6n plus 1 form or 6n minus 1 form, that does not mean that that number is a prime number. I'm just explaining it once again. A prime number can be expressed in the form of 6n plus 1 or 6n minus 1, just as the examples I have shown you in this slide. But on the other hand, if a number is expressed in this form, that number need not to be a prime number. For example, 25. We all know that 25 is not a prime number. 25 has factors 1, 5, and 25. So except 1 and 25, there is one more factor of 25 is there. That factor is 5. Okay. So 25 is not a prime number. So 25 can also be written as 6 into 4 plus 1. Although 25 can be written as 6n plus 1, but this is not a prime number. Similarly, 78. 78 is or 77. Let's take 77. 77 is again not a prime number. It can be written as 6 into 13 minus 1. Again, not a prime number, right? So not all the numbers of this form are prime numbers, but prime numbers are of this form. सारे नंबर इस फॉर्म में नहीं होंगे, बट प्राइम नंबर इस फॉर्म में जरूर होंगे. Now, which of these cannot be the sum of the consecutive prime numbers? At least two prime numbers are to be used. Check that. But before that, if you just want to take the screenshot of this slide, you can take. You can note down these 25 prime numbers and let me know if you do not want to take the screenshot or you have already noted them down. I can move on to the next slide then. So which of these cannot be the sum of the consecutive prime numbers? At least two prime numbers to be used. At least two doesn't mean that only two. At least two means either two or more than two. The first one is 52. Can you find two prime numbers which are consecutive whose sum is 52? Sum of the prime numbers which are less than, let's say 50, they are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. So what do you think 52 is the sum of which of the two consecutive prime numbers or which of the 3 or 4 consecutive prime numbers? You can check that from this. So 52 is 23 plus 29. Okay, so 52 is the sum of two consecutive prime numbers. What about 17? The prime number should be consecutive ones. So 17 can be the sum of 2, 3, 5, and 7. Right? 2 plus 3, 5 plus 5, 10 plus 7, 17. So 17 is also possible. Question is saying at least two prime should be used, not the exactly two. It could be more than two also. Similarly, 42. If you look at the prime numbers here, you can check that 42 can be written as 23 plus 19. This is 42. So that means 52, 17, 42, all of them can be written as the sum of two consecutive prime numbers. So answer has to be 14. 14 cannot be written as the sum of two consecutive or three consecutive or four consecutive prime numbers. You can check that from here. In order to get 14, either you will use 2 plus 3, 5. That is not possible. After that, either it is 3 plus 11, but they are not the consecutive prime numbers. Obviously 5 and 7, they are skipped now. Okay, so 14 cannot be written as the sum of consecutive prime numbers. The rest of the three can be written as. Next it says if p is a prime number greater than 5, then what is the remainder when p is divided by 6? P is a prime number which is greater than 5. What is the remainder when p is divided by 6? Now for this question, best is that you take the prime numbers greater than 5. Let's say I have taken 7. So what is the remainder when 7 is divided by 6? Remainder is 1. So that means option 2 could be the answer. But third option also says that 1 or 5. So you have to check that whether it is possible to get the remainder 5 also. Yes, that is. If you take the, let's say, next prime number, which is 11, divided by 6, you will get the remainder as 5. Either you will get the remainder 1 or you will get the remainder 5. The answer has to be option number 3. Let us skip this one now. Test of divisibility. So sometimes the test of divisibility will be very important while solving the questions when you have to decide whether a particular number is divisible by some number or not. The test of divisibility will come into play. The test of divisibility by 2 is very simple. 2 means the number should be even, right? The unit digit of the number should be 0, 2, 4, 6, etc. Actually, what happens is 2 is nothing but 2 can be written as 2 power 1. So since the power is 1, you just check the last digit of the number. Last digit of number. If the last digit of the number is divisible by 2 or it is 0, we generally see that the number is divisible by 2. For example, 120 has 0 as the last digit, 138 has 8 as the last digit, this number has 2 as the last digit. So for 2, we generally check the last digit of the number. It should be divisible by 2 or it should be 0. Now, in the case of 4, 4 is 2 square. So when 2 square power is 2, then we use the last two digits. We check the last two digits of the number. Last two digits of the number. That means if the last two digits of the number are 0 or they are divisible by 4, then number is also divisible by 4. If the last two digits are 0 or they are divisible by 4, then number will also be divisible by 4. For example, in this case, let's take this number. You have 64,876 and you need to check, you want to check that whether this number is divisible by 4 or not. For that, just check the last two digits of this number. The last two digits are 76. So is 76 divisible by 4? Yes, it is divisible. Now, since 76 is divisible by 4, this whole number will be divisible by 4. Answer is yes. Now, check the next number. The last two digits are 62. And we know that 62 is not a multiple of 4. 62 is not divisible by 4. Now, since 62 is not divisible by 4, this whole number cannot be divisible by 4. Okay, so for the divisibility of the 4, we just check the last two digits. Either they should be divisible by 4 or the last two digits should be 0 only. And the next power of 2 is 3. The number becomes 8. So when you come across the number 8, 8 is nothing but 2 cube. Now for that, you check the last three digits. So if the last three digits of the number, they are 0 or divisible by 8, we say that the number is also divisible by 8. For example, if I take the number to be, let's say 3253100. Now since this number has three zeros at the end, so this number will definitely be divisible by 8. Moreover, if I take the number to be, let's say 578213216. Now this is the number. The last three digits are 216. So now check whether 216 is divisible by 8 or not. Yes, it is. Right? It is divisible by 8. So since 216 is divisible by 8, this whole number will also be divisible by 8. And you can carry on this concept to the next numbers also, which are in the powers of 2. For example, for 16, it is 2 power 4. So you will check the last 4 digits. 32 is 2 power 5. So you will check the last 5 digits and so on. Now for 3, a number is divisible by 3 if the sum of the digits of that number is divisible by 3. For example, 58321 5, let's say this is the number with us. Okay, now in this number 5,83,215, in this number we need to check whether this number is divisible by 3 or not. Just add the digits here. 5 plus 8 plus 3 plus 2 plus 1 plus 5. The sum becomes 13 plus 3 16, 18, 19 plus 5 24. Sum is 24. Now 24 is divisible by 3. That means this whole number will also be divisible by 3. Okay, take the example of 23,781. Just add the digits. 2 plus 3 plus 7 plus 8 plus 1. Sum is 21. As 21 is divisible by 3, this number 23,781 will also be divisible by 3. Now the same rule applies for the 9 also. 9 also has the same rule. If the number is divisible, a number is divisible by 9 when the sum of digits of the number is divisible by 9. If the sum of digits is divisible by 9, number will be divisible by 9 also. The same rule which is for 3 is applicable for 9 also. For example, this is the number with me. Now if you add up the digits here, it will be 4 plus 6 plus 3 plus 2 plus 3 plus 9. So sum becomes 27. Now this sum is 27, which is divisible by 9. That means this whole number is also divisible by 9. It is also divisible by 9. For 4, I told you that last 2 digits need to be checked. I told you that. For 5, the last digit, the unit digit should be either 5 or 0. If that happens, the number will be divisible by 5. For 6, the number is divisible by 6 if it is divisible by both 2 and 3. If the number is divisible by 2 as well as 3, then the number will be divisible by 6 also. I'm using the word and here, not or. So number has to be divisible by 2 and 3 both, then it will be divisible by 6. For 8, I told you that last 3 digits need to be checked. For 9, number is divisible by 9. I told you that sum of digits should be divisible by 9. And for 11, the rule is a little bit different for 11. For 11, what you will do is you will find a difference of the sum of the digits at the odd places and the sum of the digits at the even places of the number. For example, we have this number with us. Let's say I'm just writing down the random number. Let us take another digit here. Let's say this is also 8. This is the number. Now I need to check whether this number is divisible by 11 or not. What I will do is I will find the sum of digits at odd places, not the odd digits, at odd places. This is the first place, this is the second place, this is the third place, fourth place, fifth place, and sixth place. So odd places means the digit which is at the first place, 7, digit which is at the third place, which is 4 here, and a digit which is at the fifth place, 8. Their sum is 19. Find the sum of digits at the even places. Sum of digits at even places. Even place is second place, which is 2. Even place is 4, which is 9. Digit is 9 here. And after that, it is sixth place, which is 8. Sum is 19 again. Now, after that, find the difference of these two sums. The difference comes out to be 0 here. So this difference should be either 0 or a multiple of 11. Difference should be either 0 or a multiple of 11. If that happens, number will be divisible by 11 also. That is the rule. So difference between the sum of the digits at, it should not be the odd digits. It means sum of the digits at the odd places and the even places. If the difference is either 0 or a multiple of 11, then number is also divisible by 11. Now, in this case, I'm getting the difference to be 0, but even if the difference is a multiple of 11, even then the number would have been divisible by 11. I think this rule is clear to everyone. Next, for 12, we have 3 and 4. If the number is divisible by 3 as well as by 4, the number will be divisible by 12 also. For 15, it will be 3 and 5. For 25, the last two digits should be divisible by 25. If the last two digits are divisible by 25, the number is also divisible by 25, or they should be 0 also. And for 75, it is just the divisibility of 25 and 3. If the number is divisible by 25 and 3, it will be divisible by 75. Since 75 can be factorized as 25 into 3, and 25 and 3, they does not have anything in common. Okay. Now, before this question, I just skipped one here. First of all, try to solve this one, because the next question is almost same as this one. The only difference is that number in this case is 504. In the next question, the different number is a larger one. So if the product of three consecutive integers is 504, then their sum is product of three consecutive integers is 504. So try to find the number by which 504 is divisible. There are three ways to solve this question. I'm just doing the first part, the first case, the first method. 5 plus 0 plus 4. 5 plus 0 plus 4 is 9. That means this number is divisible by 9. If I divide this number by 9, the quotient would have been 56, right? So 504 can be written as 9 into 56. Now question says this is the product of three consecutive numbers. Now around 9, I need to take two another numbers whose product is 56. So obviously those numbers would be 7 and 8. That means 504 is the product of three consecutive numbers, and those numbers are 7, 8, and 9. Okay, and question is asking for their sum, so sum has to be 24. 7 plus 8 plus 9 becomes 24. This is the one way to solve this question. In the second method, what if I use the number, if I take the numbers to be say n minus 1, n and n plus 1. Let's say these are the numbers, three consecutive numbers whose product is 504. So n minus 1, n and n plus 1. If I multiply these numbers now, their product should be 504. I am multiplying these two. I can write it like n into n minus 1 into n plus 1 equal to 504. So this is n into n minus 1 into n plus 1 will be n square minus 1. N minus 1 into n plus 1 is n square minus 1, or it is n cube minus n. That means after taking the cube of a number, if you subtract that number from the cube, the result should have been 504. So that means you need to think about a number which is a perfect cube close to 504. And if you know about the cubes a little bit, you will find that 512 is a cube of 8. 512 is the cube of 8. That means if you take the cube of 8, no, x, 2x, 3x, they are not, Asta, they are not the consecutive numbers. That simply means one number is 1, second one is 2, 3. But if you take x to be, let's say 2, the numbers would be 2, 4, and 6. In the first case, they are consecutive, but in the next, they are not consecutive. So do not multiply, take them to be +1, -1. Now you put any value for n here, you will always get 3 consecutive numbers. Okay, Asta? Now think, I told you that thing about a perfect cube which is close to 504, and if you know about the cubes, you will find that 512 is the perfect cube of 8. So that means this is nothing but 8 cube minus 8, which is 504. So the value of n comes out to be 8. So if the value of n is 8, this number will be 8 minus 1, 7. This is 8. The next one would be 8 plus 1, 9. So numbers are 7, 8, and 9. So either you can find the numbers by using the cube, or you can do a little bit hit and trial to get the numbers. 504, 5 plus 0 plus 4 clearly tells me that this number is divisible by 9, since the sum of digits is coming out to be 9. So this number is divisible by 9. So I divided that number by 9. The quotient came out to be 56. So 504 is nothing but 9 into 56. This 56 further can be written as 7 into 8, so that we get 3 consecutive numbers. Now on the same logic, this question is there. This is the same question with the same logic. The only difference is that instead of 504, now you have 15,600. You have 15,600 now. If you want to do this question by hit and trial, you will find that this number is divisible by 25, because the rule of 25 says that number is divisible by 25 if the last 2 digits are divisible by 25 or the last 2 digits are 0. In this case, the last 2 digits are 0. So number is divisible by 25. And if I divide it by 25, the quotient that I will get is 25, 6 of 150, 660, 624. The quotient would be 624. And that means 15,600 can be written as 25 into 624. So obviously I need to break 625 in such a 624 in such a way that I get numbers consecutive to 25. So that would be 24 into 26. That means the numbers are 15,600. The numbers are 24 into 25 into 26. And question is asking for the sum of the squares of these integers. So answer is simply sum of the squares of 24, 25, and 26. That can be done now. This would be 24 square is 576. This is 625. This one is 676. If you add up, I think answer would be option number 4. Now this is one way to solve the question, but in the other way, again, if I take the numbers to be, let's say, n minus 1, n and n plus 1, these are the three consecutive numbers whose product is given to us as 15,600. So if I multiply them, n minus 1 into n plus 1, just like the previous case, and I'm just writing the result directly now, it would be n cube minus n. That means you now think about you have to think about a perfect cube which is close to 15,600. The reason being, n cube, the cube of a number, you take that and subtract that number from that cube, the result has to be 15,600. So we now need to think about the cubes close to 15,600, and one such cube is 25 cube. 25 cube is 15,625. And the difference of 15,625 and 15,600 is 25. So that simply means this is nothing but 25 cube minus 25. So the value of n comes out to be 25. So put that value here. The numbers are 25 minus 1, 24, 25 or 26. The rest is the calculation part. I hope it is clear now to everyone. Now check this question. Which of the following is exactly divisible by 99? Now number is divisible by 99 if it is divisible by both 9 and 11. Since 99 can be written as 9 into 11. So number is divisible by 99 if it is divisible by both 9 as well as 11. So you need to first of all check the numbers which are divisible by 9. Divisibility rule of 9 says that sum of digits should be divisible by 9. So let's check that. 4 plus 3, 7 plus 2, 9, 9, 18, 4 plus 3, 7 plus 2, 9. So this number is divisible by 9, right? Let us first of all reject those numbers which are not divisible by 9. 1 plus 3, 4 plus 5, 9, 16, 25, 27. Again, this is again divisible by 9. Now 8 plus 3, 11, 16, 23, 25, 29, 29 and 3 is 32, 36. This is also divisible by 9. And 9 plus 3, 12, plus 4, 16, 24, 28, 30. This is not divisible by 9. Last number is not divisible by 9. Okay, now first three numbers, they are divisible by 9. Now we need to find which among these is also divisible by 11. For that, we need to find the sum difference of the sum of the digits at the odd positions. In this case, it is 4, 2, 4 and 2. So 4 plus 2 plus 4 plus 2 minus the digits at the even positions, which are 3, 4 and sorry, not 3, 4, 3, 9 and 3. Second position, fourth position, sixth position. So 3, 9 and 3. Now this is 4 plus 2, 6 plus 4, 10 plus 2, 12 minus 15, not equal to 0 or not neither a multiple of 11. So this number is not divisible by 11. Similarly, check the next one. Odd are 1, odd position are 1, 5, 9, 4 and 2. So 1 plus 5 plus 9 plus 4 plus 2. Right, just add up the digits. 1 plus 5 plus 9 plus 4 plus 2 minus the digits at the even places, which are 3, 7, 2, 3. So 3 plus 7 plus 2 plus 3. So this will be 21 minus 15. Again, not 0 and not a multiple of 11. Difference is 6, not 0 or a multiple of 11. So this number is again not divisible by 11. So we are left with only one option. So that has to be option number 3. If you want to check that also, you can do that. Odd position is 2. At the odd position, we have 8, we have 5, we have 2, we have 3. So sum will be 8 plus 5 plus 2 plus 3. For the even part, we have 3, 7, 4 and 4. 3, 7, 4 and 4. Now here the sum is 18. Here also it is 7 plus 3 plus 4 plus 4 is 18. So difference is 0. So this number is divisible by 9 as well as 11. So it has to be divisible by 99 also. Leave this and try this one now. So will you try this? Take 2-3 minutes. Try to solve this one. It says this given number is divisible by 9. How many pairs of the values A and B are possible? The given number is divisible by 9. Okay, so question says that this number 245867B, this is divisible by 9. How many pairs of A and B are possible? Now, a number is divisible by 9 if the sum of digits is divisible by 9. Now, what is the sum of digits here? Also, A and B, they are digits. Sum of digits. Sum of digits is 2 plus 4 plus 5 plus A plus 6 plus 7 plus B. This add up to 24 plus A plus B. Okay, so this is the sum of digits. Now question says this number should be divisible by 9. That simply means 24 plus A plus B should be divisible by 9. That means 24 plus A plus B should be a multiple of 9. But 24 plus A plus B means you are going to get a number bigger than 24. So after 24, the multiples of 9, they are 27, 36, 45 and so on. So if you take 24 plus A plus B equal to 27, that means the value of A plus B will be 3. If you take 24 plus A plus B equal to 36, that means the value of A plus B will be 12. If you take 24 plus A plus B equal to 45, that means the value of A plus B will be 21. Obviously, this is not possible. The reason being A and B are the digits. At max, they can be 9 and 9. So if you take A and B to be 9 and 9, their sum would be 18. It cannot be 21 in any case. So that simply means we have just these two cases, that A plus B either can be 3 or their sum can be 12. Now we need to make the cases for these two subcases, these two cases. The first one is, what if A plus B is 3? Right? What are the possibilities? One is A is 0, B is 3. Second is A is 1, B is 2. Third is A is 2, B is 1. Fourth is A is 3, B is 0. That means in this case, we have 4 possibilities for A and B. In the next case, if A and B, their sum is 12, then we can have the possibilities like 0 plus 12, not possible. Reason being B cannot be 12. Similarly, B cannot be 11, B cannot be 10. The first value that B can take is 9. So if B takes the value 9, A will be 3, or it could also be 4 plus 8, it could also be 5 plus 7, it can be 6 plus 6. Nothing is written about the digits, they could be same also. It is not written that A and B are distinct. If A and B are given to be distinct, then we will not take this case 6 and 6. Next could be 7 and 5. Next could be 8 and 4 and 9 and 3. So how many values are possible here? 1, 2, 3, 4, 5, 6 and 7. So 7 cases are possible when A plus B is 12. So 7 cases are possible when A plus B is 12. 4 are possible when A plus B is 3. So in total, I can say that total we have 7 plus 4, 11 pairs possible for A and B, so that this number is divisible by 9. We can make 11 such numbers which are divisible by 11, which are divisible by 9. Okay, so A and B, they can take 11 values. I'll try this one. What should be the answer? 86 into 37 minus 37 into 85. Just take 37 common. You will get 86 from the first part, 85 from the second part. So you will get 37 into 1. Answer has to be 37. Although you can multiply the numbers independently and then subtract the results, but that will make calculation little bit tougher. So it is better if you take the number common from the two numbers. That will make the calculation easier. Now this one. N is an odd integer. Which of the following must be odd? Right. No, Astha. Check again, please. N is an odd integer. So just take N to be any odd integer. Let us say N is 3. Let us take N to be 3. So this will be 3 plus 3, 6. So this is not odd. 3 plus 3 plus 3 will be 9. This is odd. 3 into 3 into 3, obviously you are multiplying 3 odd numbers. So answer has to be odd. So 2 and 3. Option number, oh sorry, yes, you are right. I just thought that there are only 4 options. I was looking at this option. My mistake. Answer has to be option 4. You wrote down option 4 and I just came to my mind. I just looked at the last option. Yes. So if n is a negative number, you can take n to be, let's say, minus 2. This will be 2 into minus 2 or minus 4. Square of a negative number will be 4, which is positive. Here it will be negative again. So answer is option 2 only. So this was all about this session on numbers, in which we just discussed the types of the numbers, divisibility rules, and some questions on numbers where you can check that if we just change the type of numbers to from integers to rational numbers or integers to natural numbers, whole numbers, etc., the whole answer is going to be changed. Now, apart from that, if you people have any doubt, you can discuss here now. You can ask me if you want to ask something about the course or the session, etc. Asad, that is actually there are different batches, so sorry, different timings. So I cannot comment on what time could be there, right? That is a different thing, because it could be in the let's say 7 o'clock, 6 o'clock. I cannot actually I cannot comment on that on the timings. So okay, thank you to all of you. Have a nice day.